Shift registers are used in order to move data laterally within the register, as we already had seen. Yeah? We could have the shift towards right or shift towards left. Or we can say shifting towards the MSB or LSB position, the most significant bit or the least significant bit. In the simplest case, we can say that the shift register could be composed of a series of the flip-flops, D flip-flops in this case, which are connected in a row as you can see here. So basically the output of the first flip-flop is connected to the input of the second one, the output of the second one is connected to the input of the third one, and so on and so forth. They all receive the same clock. So clock pulse CP is connected to the clock input of all of them, and therefore they will be updated at the same time. The data input in is connected to the, in this case we can say that it's connected to the most significant input. When we have the shift towards the right, it could also be connected to the least significant bit when we have shift towards the left. And we will have the output, the data output out, which is called as the serial output. So in is called serial input here, and out is called the serial output. The shifting of the data in this case is being done in a serial way. Yeah? The data are moving in towards the left or towards the right in a serial way. We also have access to the output of the flip-flops, all of them. So we can say that over here we can take this value A, B, C, and out, and we have access to them at any time instance, regardless of the clocking, let's say, and we call this as the parallel output. So we have access to the parallel output of the shift register. Over here we can see how the shift register in this simple form works. Again, here we have the input, over here we have the output. The D-type flip-flops are connected to each other in this way, and they all receive the same clock pulse. In this table here we have several columns. In the first column we have the clock pulse. You can say that at T0 we have the first rising edge, then at T1 we have the next rising edge of the clock, and so on and so forth. Each time that we have the rising edge of the clock, the content of the flip-flops will be updated, and in other words, a shift will be performed. So let's follow it. Just some rows are filled for us. We assume that the in is the data that we receive. So initially it is 0, then for the next clock pulse it is 1, then 1 and 0, 1, 1, and 1. So we don't have any control, let's say, on this. Yeah? We just receive it. And then A, B, C, and out are the output of the flip-flops. Initially we can say that we don't know what data we have in A, B, and C. But then when we receive the next rising edge of the clock, the 0 that we already had will be copied into, for in, will be copied into A. So A will have the value of 0. We don't know what we had for A, B, C, and out previously, but they will kind of be copied into B, C, and out in the way that you see here. Then when the next rising edge of the clock comes, when it arrives, the value of 0 that we had for A will be copied into B, and A will be updated by the input, which is 1 now. So we will have 1 and 0 for A and B, and for C and out we don't know what we had in it. Next time, this 0 that we have for B in the next rising edge of the clock will be copied into C. B will be updated by A, and A will be updated by in. So we will have 1, 1, 0 for A, B, C, and for out we have the value from the old C. Now I think it would be easy to fill the table. The remaining rows of the table will be filled like this. the value of C will be copied into C out, so we will have 0 here, 1 will be copied here, 1 will be copied here, and the in value will be copied into A. In the next rising edge of the clock, we will have the same operations happening. And finally, for the last one, 1 will be copied here, 0, 1, and 1, and so on and so forth. If you look at the content of A, B, C, and out, you should also see that the content is shifting towards the right. So this is basically how the shift register in the simplest form works.